let's try to solve this question here. So the circuit in the figure includes a battery with finite internal resistance of R, which is equal to 0.05 ohm. So they give you the value for this internal resistance over here, which is 0.50 ohm. Now they ask you to determine the current flowing through the 7.1 ohm and the 3.2 ohm resistor. So they're interested with the I for this resistor and this resistor here. Then after that, the current flows through the battery, which is the current flowing through the battery over here. Then the potential difference between the terminal of the battery, which is V across here. Okay, so if you look at this question over here, you can see that there's only one battery connected to 5 external resistances. So for this case, because there's only one battery, we are going to solve it using series and parallel circuits, which involve us labeling the diagram first, rearrange it if necessary, then we combine them to find effective resistance, then we reverse it to determine the individual currents and voltages. Okay, so I'm going to use this diagram over here, but I'm going to shift it to the next page in order to have more space to draw the diagram. Okay, so the first step will be to label, which is to give names to all the resistors that we have here. So I'm going to give it according to this order over here, which involve the 4.5 ohm here being R1. R2 will be 1 ohm. R3 will be 3.2 ohm. R4 will be 7.1 ohm. Whereas R5 here will be 5.8 ohm. So I'm going to give names to all the resistances over here because each resistance deserves a unique name for us to keep track of the resistances clearly. Okay, we also have the internal resistance and the value is 0.5 ohm, I think. Okay, so let's label it as 0.5 ohm. And since there's only one battery over here, we can just label it as epsilon is equals to 12 volt. Okay, so now everything is given a unique name. We continue by seeing whether it's necessary for us to rearrange the circuit or not. For me, there's no need to rearrange this circuit because I can see very clearly that R4 and R5 over here, they are connected in a series because you can see that one of their legs or R4 is connected to one of the legs of R5. Okay, this is happening on one legs, whereas the other legs cannot directly connect between R4 and R5. So we can say this is a series. Okay, if it's one leg connected directly, that's series. If it's two legs connected directly, that will be parallel. So in this case, there's only one leg connected directly between R4 and R5. So this is R4 and R5 in series. And once you connect it together, become one resistor R45, you can combine them parallelly with R3 as... Oh no, you cannot combine them parallelly with... Yes, you can. You can combine R3 and R45 together parallel. Let me sketch it to make it clearer, okay? I think talking would not help much. Let's sketch it out. Okay, so what I'll do right now is I'll be combining R4 and R5 together and I'll combine them in series. Okay, you might be thinking, is it possible that it's parallel? Well, if it's parallel, it has to be two legs connected directly. So R4 will have its left legs connected to the left legs of R5, but that is not the case. You have R3 in the middle blocking it. So therefore, it is not a parallel connection. Then if you check whether it's a series connection, yes, it is because one leg is touching between R4 and R5. So you combine them using series. So the result of the combination will be you having resistor R1 still here, your battery internal resistance, your battery epsilon, your resistance over here, another resistance. Okay, so let's label. This should be R1, this should be R2, this should be R3, this should be small r and epsilon. Okay, then continue over here, you have your R4 connected to R5 as well. Okay, let's combine in a way easier to see. R4 and R5, they're connected in series, so let's put it over here. There's one single resistor, R45. Okay, so what happened is R4 and R5 over here are connected in series. Okay, next you can see very directly that R3 and R45, their top legs are connected to each other, their bottom legs are also connected to each other between R3 and R45. So this is a very clear parallel connection. So we are going to connect, we're going to combine R3 and R45 here in parallel. We're going to combine them in parallel. Okay, so the combination will be still have R1 over here, still have R2, still have R345, and you have your internal resistance and also a EMF. Okay, so this is R1, this is R2, this is R345, and this will be small r and epsilon. Okay, now what's left here is R1, R2, and R345. You can see that the one legs are connected between R1 and R2. One legs are connected between R2 and R345. So these three resistors here are connected in series. So we are going to combine them in series. Okay, oops, it should be in series. Then lastly, I believe your diagram will be just internal resistance and also the battery connected to one single resistor. I'm going to label this as R, this one as epsilon, this one will be a combination of everything, R1, 2, 3, 4, 5. Okay, so we have already figured out how we are going to combine the resistors step by step to get the effective resistance. So now we can perform our calculation. If it's in series, you have to just add them up. If it's in parallel, we have to do 1 over 1 over. You have to reciprocal your resistance value. Okay, so let's start with R45 first. R45 is just a combination of R4 and R5 in series. So series, you are going to just add them up. So R4 is 7.1, R5 is 5.8. So if you add them up, you get 12.9. Afterwards, you know that R3 and R45, they're connected in parallel. So if it's in parallel, you have to invert your resistance value before you substitute. It will be 1 over R3 plus 1 over R45. Okay, you invert the value first before you substitute. This will be 1 over R3 will be 3.2, R45 will be what we calculated earlier, 12.9. So if you put it into your calculation, I believe you get a value which is 2064 divided by 805. I leave it in fraction because if I put it into decimal, it will be an irrational number with a long decimal places. So I keep it in fraction, then it will avoid me from rounding up my answer halfway during the calculation. I keep it in fraction so that I do not need to round it up. Okay, next I will be combining R1, R2, and R345. They are connected in series. So what I need to do is just add them up. So R1, 2, 3, 4, 5 will be a combination, just a simple summation of R1, R2, and also R345. So R1, the value will be 4.5, R2, the value will be 1.0, R345, the value will be 2064 divided by 805. So if you sum these values up, I believe you'll get an answer of 12983 over 1610, or if you choose to make it into decimal, it will be 8.06. Okay, so this is us combining R1, R2, and R345 together. Okay, so this process here we call it as combine, in which we combine step by step the resistance in order to obtain an effective resistance. Next, what are we going to do is we are going to reverse the process over here to go from the last diagram on the right to the first diagram on the left. Okay, reverse, not reserve, sorry. We are going to reverse steps over here. So it starts with the last diagram, internal resistance, battery, connected to R1, 2, 3, 4, 5. Okay, you draw the the second diagram, second last diagram, where you have your internal resistance, you have your battery, EMF, oops, sorry, you have 3 resistors connected in series. So let's sketch it out. 3 resistors, first one, second one, third one. Okay, so this should be R1, R2, and R345. Then this should be small r and epsilon. Okay, you continue your reverse, the third last diagram that you have. Again, you have your internal resistance and your battery. That is still the same. You have your R1, you have your R2, you have your R3, you have your R45. Okay, label everything clearly. This one is R1, this one is R2, this one is R3, this one is R45. And lastly, you revert back to the first diagram, the diagram that you received in the question. You have your R1, R2, R3, R4, and R5. Okay, so let me label it R1, R2, R epsilon, R3, R4, R5. So everything is labeled clearly. Now I will just reverse my process starting from the first diagram on the left. Okay, I happen to know that R1, 2, 3, 4, 5 is equals to 12983 divided by 1610 ohm. That's the resistance. And I am aware that epsilon is equals to 12 volt and internal resistance is equals to 0.50 ohm. So well, I know that R12345 here is outside the battery, so I can consider it to be our external resistance, whereas this small r over here will be our internal resistance. So there's two things that I can calculate here. First, I can use the first equation for internal resistance and EMF. R plus R effective, but our R effective in this case will just be R12345. So from here, the value that I calculate over here will be the current outside battery or inside battery is the same, maybe I12345. Okay, so the idea is very simple. Well, what's coming out from the battery will be supplied to the resistance R12345, right? So the current flowing through the battery will be the same as the current flowing through R12345. That's why this current here is I12345. Because it's a current that flows through the battery, it's a current that flows outside the battery. It's the same current. Okay, so we can perform our substitution. Then you have 0.5 plus R12345. R12345 is 12893 divided by 1610. So from here you can get I12345. Oops. Let me write here. I12345 in this case will be 1610 divided by 1149. Okay, at the same time, there's also one more thing that you can calculate. You can calculate the terminal potential or the terminal voltage. The terminal voltage is V12345. And that's right here. V12345 and V12345 will be equals to I12345 multiplied by the external resistances ineffective. Okay, effectively our external resistance is 12345 as well. Okay, so we can plug it in 1610 divided by 1149. Resistance 12345, it's 12983 divided by 1610. So from here you can get V12345. V12345 will be equals to 12983 divided by 149. Okay, so this is based on the first diagram. This is based on the first diagram. This is also based on the first diagram. Okay, we have managed to obtain our V. We have managed to obtain our I, and we have our R from earlier. So we have V, I, R all complete. We can move on to the next diagram. So this is how we reverse. Every single diagram, we make sure we determine the voltage, we determine the current. Once you have done both, we move to the next diagram. So the next diagram, we can see that R1, 2, 3, 4, 5 is being splitted into R1, R2, and R3, 4, 5. This is a split that happens from R1 to 3, 4, 5. R1 to 3, 4, 5 become R1, R2, and R3, 4, 5. This is breaking it up in series. So we know that if it's related to series, the current passing through R1, R2, and R3, 4, 5 should be the same. Okay, so let me use another color because I enter the next diagram. So I know that the current is the same, so the current flowing through R1 will be the same as the current flowing through R2, will be the same as the current flowing through 3, 4, 5. And that will just be equals to I1, 2, 3, 4, 5, the combination of all the current. So the combination of all the current is just 1610 divided by 1149 ampere. Where do I get this? I get this from the previous calculation of 1, 2, 3, 4, 5. Okay, I know that the current is equal for these three resistance, but I know that the voltage will have to be added up. So the voltage V1 will be added up with V2, will be added up with V3, 4, 5. And from here, you can get V1, 2, 3, 4, 5. V1, 2, 3, 4, 5, again, you have obtained from earlier. V1, 2, 3, 4, 5 is equals to 12983 divided by 1149. I'm keeping everything in fraction because I just don't like to round out halfway during the calculation, so I leave everything in fraction. It's not wrong to leave it decimal, it's okay as well. Okay, so right now I reached this point. Technically I have all my current already. I1, I2, I3, 4, 5. I have all the values because the value is given over here. But V1, V2, and V3, we don't know each individual value. How much is it? What we know is that the sum of V1, V2, and V3, 4, 5 will become this value over here. But we don't know as an individual, V1 is how much, V2 is how much, V3, 4, 5 is how much. So we'll continue to determine V1, V2, and V3, 4, 5. But actually, you only need to look for things that you are interested to find. Okay, let's go back to the question. The question interested with the current flowing through 7.1 ohm and 3.2 ohm. 7.1 ohm is over here. It's our R4. So technically, we are interested for question A, we are interested in I4. Then they are also asking for current flowing through the 3.2 ohm resistor. 3.2 ohm resistor is over here. I labeled it just now as R3. So what I'll be interested for question A is actually I3 only. Okay, next, how much current flows through the battery? That's the current flowing in the battery and outside the battery. So that will be current that we already determined over here. That will be I1, 2, 3, 4, 5, because that's the current flowing through the whole battery as a whole. Then the potential difference between the terminals of the battery, that is just terminal voltage. When we talk about terminal voltage, is what we measure across the battery, and that will be equals to V1, 2, 3, 4, 5. Okay, so what we're interested with is only I3, I4, I1, 2, 3, 4, 5, and also V1, 2, 3, 4, 5. Nothing more than that. So if there's anything that is not required by the question, we don't need to calculate it actually. So if you come back to this thing, this work we have over here, we are only interested with 3 and 4. We are only interested with values related to R3 and R4. So 1, 2, and 5, they're actually not really related to our question. So V1 and V2 here, even though we don't have the value, technically we don't need to find it because we are not interested with anything that happens to resistance 1 and anything that happens to resistance 2. We are only interested in what's happening to I3 and I4. And 3 and 4 happens to be inside V3, 4, 5. There's 3, there's 4 over here. So we need to calculate V3, 4, 5. Okay, so V3, 4, 5 over here, again, to determine this voltage, this current, there's only one equation to be used, which is V is equals to IR. So you need to make sure that you have the same subscript. If you use IR, then it will be I345 and R345, the same subscript. Okay, I345 can be obtained from just now. I345, the value will be 1610 divided by 1149. But how about R345? R345 is a combination of 3, 4, and 5, right? We have R345 over here. That's 2064 divided by 805. 2064 divided by 805. So if you calculate it, you get V345 to be equals to 1376 divided by 383 volt. Okay, so you are near there. You're already done with this diagram over here. Next, let's move on to the next diagram. Because you have V305, you have I305, you have already done what the question needs. Okay, you don't need to go and find V1, you do need to go find V2. Okay, let's continue the next diagram. What are you breaking up right now? You're breaking up R345 to become R3 and R45. So let's use another color once again. You're breaking up R345 to become R3 and R45. This is breaking it up in parallel. So we know that for parallel, the voltage will be kept constant. So voltage for resistance 3 will be equals to voltage for resistance 45 will be equals to voltage across 3, 4, 5. Okay, you just need to write what is relevant, 3 and 4, 5, and their combination 3, 4, 5. And V345, if we look back, V345 is equals to what we have calculated here, 1376 divided by 383. Well, we know that voltage is equal, so what must add up? It will be the current that needs to add up. So I3 and I45 will be equals to I345. So I345 we obtained from earlier, I345 it's 1610 divided by 1149. Okay, so once you're done, again, let's look at what the question asked for. The question asked for I3 and I4. You have I3 and I4, 4 is inside here, so both of these need to be calculated because 3 is relevant to what we want to find. For 5, we are interested in the 4. So, oops. So let's find the first one, which is I3. Again, you just use Ohm's law. V is equals to IR, reshuffle it, it'll be I is equals to V over R. Again, keep the subscript consistent. So if it's I3, then with V3, it'll be R3. So from here, you get V3, you know the value from up there, it's 1376 divided by 383. Where do you get it from? You get it from here. V3 is equals to this value. R3 is equals to 3.2. So you can divide this value by 3.2 and you get your current I3. So current I3 will be equals to 430 divided by 383 ampere. Okay, so that's I3. Next, we need to find I45 because we want to find the I4 later. I45 is equals to V45 divided by R45. Okay, V45, the value is 1376 divided by 383. R45, combination of 4 and 5, that will be 12.9. So if you calculate it, I45 will be equals to 320 divided by 1149 ampere. Okay, so you already obtained I3. This is part of the question for question A, but you still need to find I4. So to find I4, you have to break it open again, break it further, R45, break it into R4 and R5. So this again requires another diagram. R45 breaking it into R4 and R5. This is breaking it up in parallel. In series, sorry, in series. Almost commit the same mistake I said earlier. Only one leg is touching, so we're going to handle it as series. So series, what will be the same? Well, the current will be the same. So therefore, I4 is equals to I5 is equals to I45. Excuse me for putting it in the next line. I45, you can obtain it from earlier. I45 is 320 divided by 1149. Whereas V will need to be added on. So V4 plus V5 will be equals to V45, in which the value we have it from earlier. V45 is 1376 divided by 383. Okay, so we already calculated until this point. You might think that we might need to continue find V4 and V5 because we have I4, we have I5, the value is given. We need to find V4 and V5. But again, look at the question. The question interested with I3 and I4 only. And technically, I believe you can see that you have I4. I4, the value is over here. I3, the value is over here. So you actually have already successfully answered question A already. Let me highlight what we have determined. I3 is this value. I4 is this value over here. Okay, then next, they also ask for the current flows through the battery. So that's I12345. You had it from earlier, I12345 over here. Then lastly, they ask for the potential difference between the terminals of the battery. That's terminal voltage of V12345. Again, you already obtained V12345 as well. V12345 over here. So it will be V12345 equals to 12893 divided by 1149. Okay, so you have everything you need to answer this question right now. Let's probably single out so that it's easier to be checked. Let's try in blue. For question A, if they are interested with 7.1, 7.1 is R4, so that's I4. So first question, they're interested in I4, so let's answer them. I4, the value is equals to 320 divided by 1149 ampere. Okay, question B, they ask for across 3.2 ohm, right? So that will be I3. I3, the value will be equals to 1610 divided by, sorry, copy the wrong value. I3 is over here. I3 over here, 430 divided by 383. Okay, 430 divided by 383. Okay, next you have the current that flows through the battery. That's I12345 and terminal voltage V12345. So let's continue. Question B, I12345, that will be equals to, over here, I12345, the value is 16101149, same as here, 1610 divided by 1149 ampere. Then lastly, the terminal voltage V12345, which is equals to what we calculate over here, 12983 divided by 1149. Okay, I hope you can see that this question, even though it's much more lengthier compared to the previous series parallel question, but you can see that it's still the same process over here. You start by giving unique names to all the resistors, then you rearrange it if it's difficult to be read. In this case, it's quite easy to be read, so I keep it in the same configuration that I was given with. Then after that, I start with the combine process, in which I see how I'm going to combine the resistors in either in series or in parallel to form one single resistor and to find the effective resistance. I combine in series first because it's connected with one leg only, the other leg is not connected directly. Then I connected R3 and R45 in parallel because both legs are in contact directly. Then R1, R2 and R345 are connected in series to form R12345. So the combination process allows me to determine the effective resistance of the circuit. Then I reverse the process from the last diagram to the first diagram, reverse it step by step. For every single diagram, I determine the voltage and also the current. So in this case, I already have the resistance. I determine the voltage V12345. I determine the current I12345. Then I move on to the next diagram. For next diagram, the same thing. I determine the current and I determine the voltage. For this case, voltage will need me to use the Ohm's law. Next diagram, again, determine V and I relationship. Again, I'm going to find I3 and I45. I45 is then used for us to determine the I4, and I4 is equal to 320 divided by 1149 ampere. Okay, so this process here involving me combine then reverse, and for every picture that I reverse, I need to make sure I know what is kept constant, what is added. Then from there, I can know which value do I need to determine, which value is not interested by the question. So if you solve this kind of question through many practice, I believe you see that it's actually a very direct question, and the steps are always the same usually. Okay, so that's it for this question. Thank you very much.